Well, good day and good afternoon. How are you doing? It's quite a while, and here we are back again. And let me tell you one thing about success is consistency and perspiration. When you are consistent with learning, I'm telling you, with time, you are going to get an awesome result. So please, I would like you to please subscribe so that you can be updated with more of our video of motions, the laws of motions. Yes. We'll be talking about motion. We'll talk about the motion, the linear motion. We'll talk about the projectile motion. We'll talk about the motion under gravity. But at this point in time now, we want to talk about the laws of motion. But before that, we need to discuss about what we call the linear momentum. Yes. You see, when we talk about these laws of motion, we actually did not discuss about the forces that causes this motion. But with respect to this topic, we are going to discover the forces, how the motion started, what happens to bodies at rest and bodies in motion. So at this point in time, we'll talk about linear momentum. So linear momentum, from the word linear, horizontal, momentum, the emphasis here is actually momentum. So we are talking about, it is a product, momentum, is represented by this symbol, is a product of the mass and the velocity. Yes. Yes, momentum is a product of the mass and the velocity. So what is mass? The unit of mass is what? Is kilogram. And the unit of velocity is what? The unit of velocity is meter per second. So at the end we can say kilogram times meter per second to give you kilogram meter per second. So that's the unit of momentum. So momentum, the unit is what? Kilogram meter per second. So that's it. It's the product of the mass and the velocity. Now, it's even a vector quantity. Yes. The momentum is a vector quantity because the mass is in kilogram, which is scalar point, but it's acting at a speed in a specific direction. The velocity is acting at a direction. So momentum is what? Is a vector quantity. Now that will take us to the next thing, the impulse. Yes. So at a point in time when you, like as I said in one of our videos, that if I should hit this thing now, there is a force. I apply the force on this board, but at the same time there is a reaction. Now, the reaction is that I feel the pain. If I should hit this wall now, bad. Yes, I applied the force, but this wall also applied a backward force to me. How? The pain I felt is the reaction of the wall. That means the wall has a reaction. So the quantity of force is the average force acting upon an object with time, within the time of duration of that force, is what we call impulse. So we can say impulse is what is a product of force and time. Yes, it's a product of force and time. So F, which is force, times time. So what's the unit of force? Force, the unit of force is what? Is Newton. And what's the unit of time? The unit of time is what? Is seconds. So we can say Newton times seconds. It will give us Newton seconds. So the unit of impulse. So we can say the formula for impulse is equal to F. Sorry, just that Ft. F is the force, T is the time in seconds, and the unit is Newton seconds. So that's it. It's a match from the experiment of Isaac Newton. So we can say it's Isaac Newton's laws of motion. And the first law of motion states that a body will continue in a state of rest, or in uniform motion unless it is acted upon by an external force. Yes. The body will continue in a state of rest or in a uniform motion unless it is acted upon by an external force. What does that mean? Is that, look at this board. This board is an object. And if you can see this board now, the board will continue to be here for the next 10 years. Is the body is at rest. And let's assume I now push it. What will make this body to leave this space is if I carry it. So me carrying this body away from here now, I have executed a what? An external force. So motion, first law, as a Newton's law of motion, is actually that this body will continue to be here for years unless I carry it external force. Now let's assume a tire is rotating. A rotating tire is rotating along a definite direction or path. You see, this tire will continue to rotate forever. But what will bring this tire to rest or stop is because there are external forces that will act on it. What are these external forces? It can be force as a result of the air resistance, because when it is going, there is the tendency for the air to be opposing the motion. So the tire will be slowing down, until it will eventually come to rest. That is an external force. The tire will continue to rotate unless it is acted upon by a force due to the undulating nature of the ground. Let's say the ground is sloping upward. Yes, because of this force on the ground, the tire will tend to exhibit more energy to move. So because of that, there is an external force acting on the rotation of the tire, so it will come to rest. There can be other forces. So, but if we remove all these forces, the ground is smooth, the tire has no personal force. In fact, the personal weight of the tire alone is a force tending to bring the body to rest. Now, if there is no force or there is zero force, no external force, this tire will rotate forever. So that is what this Newton law of motion states. Now, this Newton law of motion also brings us to what we call the inertia. Inertia. What is this inertia? Once again, an inertia is the force that is acting on an object at rest or in a uniform motion, with the exception of what? Of an external force. Yeah, so that is inertia. So we can also say the first law of motion applies to what we call the inertia, but the exception is that an external force does not apply to it. So question 1 or first law of motion can also be related to the inertia principle. So please take note of that. So we are going to second law. Second law states that the rate of change of momentum, second law of motion states that the rate of change of momentum is directly or is proportional to the applied force. The rate of change of momentum is proportional to the applied force and acts in the direction of force. Yes, the rate of change of momentum is proportional to the applied force, and we can say applied force or expressed force and act in the direction of that force. So, what is the change in momentum? Of course, we won't say momentum. Momentum is the product of the mass and velocity, as we have discussed here. Product of the mass and velocity. Let me put it this way: mass and velocity. So now, but what did I say? Rate of change. Now we are taking the consideration time. I'm talking about the time momentum started, the time momentum ended. So the initial velocity and the final velocity will be factored in. So what is the change in momentum? Change in momentum now. Change in momentum is equal to mv minus mu. Yes. And the rate or the time is equal to t. Then the applied force, F force, is equal to F. So to be able to actualize the expression or the definition, the change in momentum Fv, rate of change of momentum Mv minus mu is all over t is equal to F. Now, what is V? V is equal to the final velocity. Final velocity. U is equal to initial velocity. Then T is time in seconds. Where F is equal to force in Newton. Yes. So this is just the definition of motion. The rate of change of momentum of a body or an object is proportional to the applied force or expressed force and act in the direction of the force. Therefore, we can say the second law of motion is what gives birth to the formula which is F is equal to mv minus mu over what? Over t. Now let us make m is the mass, isn't it? M is the mass. Let me write it here. M is equal to mass in what? Kilogram. So now let us collect like terms now. If you collect like terms, or we should factorize the mass out now, it's going to be mass is equal to V minus U all over T. Do you agree? Yes. Now recall that V minus U over T is equal to what? Acceleration from our earlier definition of motion. So V minus U is equal to T. So now let's come back. Let's substitute V minus U over T for this equation. So F is equal to M into bracket what? A. Because V minus U over T is equal to what? Is A. So this gives us the definition of force, which is in what? Newton. Yeah. Newton. So at the same time too, we can also say F T is equal to, okay, let me come back to the definition. F, you know, if you should cross multiply, we have Ft, which is equal to what? Mv minus Mu. If you should cross multiply over 1 now, this one come and meet this one come and meet this. So we are going to have, by the time this T come and meet this Ft, we are having Fv minus M. So we can say, remember Ft is what? Is impulse, which is what? The product of force times what? Time. Product of force times time. So which we have explained earlier. So we can say impulse on an object is equal to the what? The change in momentum, which is mv minus mv. What is momentum? Momentum is mv. Product of the mass and velocity. Product of the mass and velocity. So when you have a change now, you can also say it is equal to the momentum. So that is that for equation 2. Please take note of that. And we can also define force as a product of mass, 1 kilogram of mass, with an acceleration of 1 meter per second squared. Gives us a unit of what? 1 Newton. Yes, that is the definition of what? Of force. So now we are going to third law that to every action. As I said the other time, when I hit this board with a blow, you discover that there's a reaction of the wall on my hand in form of pain. So what is the action? Let's assume the force that I apply is what? Fa. There's an equal and opposite what? Reaction. It's not that there's an equal and opposite reaction. There's an equal. It's not that there's an equal and reaction. There's an equal, but the reaction is what is opposite. So the force I'm applying is positive, while the wall exhibited negative force. Let me say the force of the wall is FB. So this negative force is opposite, but this FB is the reaction. So the positive is the what? The action, while the negative, the FB is what? The reaction. So the positive is the action, while negative is the opposite of positive. While FA is the action, FB is the reaction, while negative is the opposite. So every action, there is an equal and opposite reaction. How can we explain that? I've made mention of when you keep this wall, you felt an opposite reaction by a pain in your hand. That is, the wall is acting on you. Now, in your vehicle, when you sit in a car, when the car is moving and you are seated in that vehicle and suddenly applies the brake, what happens to you? You discover that you tend to move forward. Are you getting it? The force that brings the vehicle to rest tends to shift your body forward. That is a reaction. Are you getting it? The vehicle comes to rest, it stops, but your body is reacting by saying, I'm moving forward. So that force that acts to that body is a reaction. Okay, what if the vehicle was at rest and you are just seated and all of a sudden the vehicle just starts from rest and starts racing? What happens to your body? Your body shifts backward. That backward shift of your body is what we call reaction. So, and it's moving, the vehicle moves forward, but your body moves backward. So that opposite reaction exhibits what? The Newton's third law of motion. So that is that. In our next lesson, we are going to talk about the application of all these laws and treat calculations on it, examples and external examinations that actually applies these laws. So I hope you enjoyed the short lecture. I'm happy that you are here, and it's really nice seeing you. Thank you very much. Subscribe on that button, like, place your comments, and see you in our next video.